Hello students and welcome back to the class. In this video, I have highlighted some of the questions or you can say the activities given in NCERT which always we ignore and we always prefer to go to some reference book. But students, reference books are good for practice once you are done with NCERT, which is the most important level of your studies when you can begin. All the questions are given so well in NCERT. If you can solve all these questions, no one can stop you from getting good marks. So students, each and every detail of NCERT is very important. So let's discuss few questions or you can say the activities thoroughly so that you will be clear with all the concepts. So let's watch it. Students, we will discuss about this 5.3 activity of NCERT. Student, for this you need to read this paragraph, like making order out of chaos, the modern periodic table, because each and everything we must get clear about it. So today we will discuss about that how were the position of cobalt and nickel resolved in modern periodic table. So for that, let's see the periodic table first. See students, here the place of cobalt and nickel. Cobalt is having atomic number 27 and 28 is of nickel, but the mass number, if you will see, mass number is more of cobalt than nickel. But according to that, what we have studied in earlier one, that the more one will be here and the lesser one will be at this place, okay, because cobalt is having more mass, so it should be here, and nickel has less mass, so it should be there. But this process was proved wrong, because in modern periodic table Henry Moseley have done opposite. What he have done, he have said that I will arrange all the elements in the form of their atomic numbers. One more thing students, atomic numbers are based on number of protons, okay, so whatever number of protons will be there, we have to count the number of electrons. Students, you can change number of electrons, you can change number of neutrons, okay, they can vary. I mean, you can change means they may vary, but number of protons won't vary, and this atomic number is totally based on the atomic, what you can say, number of protons. That's why they are always fixed, and hence we have put cobalt here and nickel at the second position. This is the reason why nickel is kept or nickel is written later than cobalt, because you cannot change number of protons, and that is atomic number. Students, our next question, which is in activity 5.3, is how were the position of isotopes of various elements decided in modern periodic table? So it was decided, as I have told you, it is completely based on, the modern periodic table is completely based on atomic numbers. So obviously isotopes are the one which has different atomic mass but same atomic numbers. So same way it has been resolved that if you are considering atomic numbers, so obviously isotopes you can place them in different boxes. You need not to pay them, or you need not to keep them in the same boxes, right? So it was resolved. And the next question which we will study is it possible, or where do you think should hydrogen be placed in the modern periodic table? So for this, let's understand the entire thing about hydrogen. Students, we will discuss about the position of hydrogen in our modern periodic table. We all know that hydrogen has similarities with alkalis and it has similarity with halogens too. But we will discuss them one by one. What are the similarity with hydrogen and alkalis? They all have electronic configuration, and you can see after doing all this electronic configuration, what you can see, all have valence electrons 1, 1, 1. In case of lithium, in case of sodium, in case of potassium, all of them have one valence electron, and hence they can lose one electron and can participate in bond formation, right? And they form different kind of compounds. So here this is the similarity with alkalis, right students? Just like alkalis, as their alkalis are similar to Hydrogen, same way. Let's see what similarities. So here we will study about, students, that what are the similarities of hydrogen with halogens. Okay, so here I have written the electronic configuration of hydrogen, fluorine and chlorine to make you assure that if I compare with the halogens, how I can show you. Hydrogen is having one electron in its outermost shell, which I am showing here. Fluorine, I have done the electronic configuration, and what I have got, the valence electron is 7 here, and here also chlorine 7. So we require one more electron to complete its octet. Same with fluorine. Same with hydrogen, we need one electron to complete its octet. So students, here we got to know that yes, hydrogen is similar with halogens because they all require one electron to complete their outermost shell. So what they will do, they will gain one electron and participate in bonding. Same way, the second point, if I talk about, if you ask me when how they are similar, again if you ask more questions, then I'll say just like halogens, hydrogen is also a gas. Like fluorine is a gas, chlorine is a gas, bromine is not a gas, it's an exceptional case. So same way, again hydrogen is a gas. Atomicity, we have studied about atomicity in class 9, student. Atomicity means if a molecule is forming with 2 atoms of fluorine, this 2 is the atomicity. Okay, this 2 is atomicity of chlorine, this 2 is atomicity of bromine. Same way, hydrogen also form, its atomicity is 2. Hydrogen 2. It also form the molecule when you combine 2 hydrogen atoms to form one molecule of hydrogen. So atomicity of hydrogen also matches with the halogens, you can say. So these are the characteristics, students, that why we are saying that the hydrogen is similar with halogens and hydrogen is similar to alkali, and still yet, hence students, the position of hydrogen is still contradictory. But for our conveniency, we all have, Henry Moseley have placed it at group 1, which falls in the group of alkali, right? So students, these all are, we have total 1 to 18 group, we all have 18 group we have in a periodic table, and we have 7 periods, right? 2, 3, 4, 5, 6, 7 periods. So don't forget that. I hope you understood this. Do it in your notebook. Take care, and we'll see you in the next class.